In the Pacific Ocean, a floating radar platform scans the skies for potential missile threats. The sea-based X-band radar, or SBX-1, is one of the most advanced radar systems in the world. At the center of that system stands a massive inflatable radome, protecting the radar from some of the harshest environments on Earth. In 2025, that structure needed to be replaced. The mission to deliver and install the new radome, known as XBR-2, would require engineering, innovation, precision logistics, and flawless execution across thousands of miles. The project began in Elizabeth City, North Carolina, where Oxbo conducted a full trial deployment of the radome. Measuring 130 feet in diameter and 142 feet tall, the inflatable structure will protect the radar system mounted on SBX-1. But transporting the radome presented a unique challenge. The structure, not able to be folded for shipment, required Oxbo engineers to design a specialized transport and deployment system. The result? The Radome Envelope Container, or REC, a custom-engineered structure designed to protect the radome during transport, while also supporting vertical deployment and rigging operations. Positioned horizontally, crews used 4 rough terrain cranes to carefully lift the structure and place it inside the REC. Once secured inside the container, 12 lines of Goldhofer PST SLE transporters powered by 2 power pack units positioned the system for the next critical step. Using a custom-engineered tripping frame and a 600-ton hydraulic crane, the REC and radome assembly was slowly tripped into a vertical position. At nearly 150 feet tall, the tight tolerance left minimal room for error, requiring precise coordination between engineers, crane operators, rigging crews, and safety observers throughout the lift. Spotters monitor the operation from multiple positions, on the ground, from man lifts, and from above, using aerial drone observation. Every movement was carefully coordinated to maintain safe clearances within the hangar. Once vertical, the REC was transferred from the transporters and secured onto its foundation, where guy wires provided stabilization for the structure. Using a custom-designed lifting ring, the radome was removed from the container and positioned into its ring wall foundation, where it would be fully deployed and inflated for inspection. The trial deployment remained in place for nearly 60 days while the owner conducted an overall evaluation and system testing. After testing was complete, the process was reversed. The radome was returned to the REC, the container was down-ended, and preparations began for Phase 2 of the project.
What we've done here and over the past year of putting together is basically a design and fabrication of a crate, uprighting a 160-foot crate in the air in about a 180-foot tall blimp hanger, and making the trial deployment and the inflation as you see behind me. We had to use a 600-ton crane that we rented from Maxim Crane Works. We used a local fabricator to build our crate and design. We used Travis with Diversified Heavy Lift for all the rigging and engineering, and we worked directly with Raytheon and their engineers to put this project together. It's been 2.5 years in the making, and now we're finally completing Phase 1.
With testing complete, the radome began its journey across the United States. With the radome secured inside the REC, the container measured 150 feet long, 20 feet 6 inches wide, and 12 feet tall, with an astounding cargo weight of approximately 200,000 pounds. Upon final transport configuration, the overall system extended to 220 feet in length, weighing more than 512,000 pounds. The move required specialized Goldhofer THP-CA hydraulic platform trailers, configured with 6 axle groups, separated by spacer decks to distribute the load safely and evenly. Over the course of the move, the convoy would travel 4,126 miles across 11 states. Initial route surveys uncovered obstacles such as construction conflicts and vertical clearance limitations. For example, in North Carolina, a planned route included an overpass that was still standing, despite records stating it had been demolished. Detecting this early allowed for a safe reroute, avoiding major delays. Furthermore, permitting issues in Tennessee presented additional threats to the project timeline. Through coordination with the Missile Defense Agency and the National Missile Defense Team, Oxbo worked directly with state agencies to maintain the tight timeline. After weeks of travel, the Radome arrived safely at the West Coast staging location, completing the journey of over 4,000 miles with 0 incidents.
Okay, so we are on phase 2 of the XBR Radome project. Last time we saw you, we were doing the trial deployment in North Carolina. Since, we've hauled this 150-foot long, 20-foot wide crate over 4,000 miles from North Carolina to Rainier, Oregon. And today we just put it on this boat you can see behind me. It's called the OSV. It's an offshore supply vessel for the SBX barge where the XBR Radome is placed at. So we just got done loading this crate on there using our 12 axles of PST SLE and 75-foot bridges to get out on the boat because of low waters. And now we'll finish up our lashing project and send it underway so we can offload it in Hawaii here in just a couple weeks.
The next phase required transferring the cargo to the marine support vessel bound for Hawaii. Along the Columbia River, Oxbo engineers developed a detailed loadout plan, accounting for obstacles such as river currents, tide fluctuations, and vessel positioning constraints to ensure the operation would be executed safely and efficiently. The REC was transferred from highway transport equipment to 12 lines of Goldhofer PST SLE transporters. Using 75-foot loading ramps, tugboats, and a derrick crane barge, the massive container was carefully maneuvered and rolled onto the support vessel, Blackwatch. Once on deck, the cargo and supporting equipment were secured according to ABS maritime standards, ensuring the structure would safely withstand crossing the Pacific Ocean. With preparations complete, the vessel departed for its 10-day voyage to Hawaii.
It'll be slow going as we get kind of out of the box and get going. Then we got to get staged, get up on the vessel, all that kind of stuff. I'll have 2 guys down here. Once we start swinging, they'll keep an eye on things. I'll have 2 guys receive the tagline over here on the starboard deck. They'll clock it for Joe as we come around to the array phase. In the meantime, I got to get up on this side, and then we'll work through that show.
The final phase of this landmark project took place at Ford Island in Pearl Harbor. The historic dock structure presented several challenges, including a 600-pound per square foot pier load restriction, limited working space, and undocumented underground utilities, requiring careful engineering to safely distribute loads and protect the structure. To address these constraints, Oxbo utilized 75-foot ramps to clear span the pier, distributing loads safely across the structure. The REC was then offloaded from the vessel using 12 lines of PST transporters and positioned for deployment. With the existing radome removed, the radar system was exposed to daylight for the first time in over 2 decades. Once maintenance activities had been completed, installation of XBR-2 could begin. Using the same custom tripping equipment developed during the trial deployment, the REC was once again raised into a vertical position. Stabilized with guy wires, the radome was rigged using Oxbo's custom lifting ring and carefully removed from the container. The structure was swung into position above the radar face and aligned with the upgraded ring wall foundation. With the coordinated effort of more than 200 rope pulling technicians, the radome was slowly deployed and secured in a carefully controlled operation. Once attached to the ring wall, the structure was inflated into its final operational form, completing the installment of the new radome. From engineering and testing to cross-country transportation, marine logistics, and final installation in Pearl Harbor, Oxbo successfully executed every phase of this complex operation. The project required more than 1,200 engineering hours and over 7,000 man-hours of field execution. Throughout the entire mission, from trial deployment to final installation, the project was completed with 0 recordable incidents.